Welcome to my tutorial on the introduction to logarithms. Logarithms are used in all kinds of disciplines. For example, the Richter scale, which is a way to measure the magnitude of earthquakes, is a logarithmic scale. Also in computer science, because binary is used to store data, logarithms are frequently used. We also measure sound and pH levels as logarithms. Alright, I know what a lot of you are thinking. Professor Serge, I've been putting pH chemicals in my pool for years, and I don't know anything about logarithms. I didn't even know pH scale was logarithmic. So why do I have to learn it now? Well, the difference between the person who puts the pH chemicals in the pool and the person who puts them in the box and designs them at laboratories is knowing logarithms. So I'm going to start with a much simpler problem to explain the basic purpose of logarithms. In fact, embarrassingly simple. If I have an input 5 and I add 3 to that, I'm going to get 8. Now if I take 8 as my output and make that my next input, and I do a subtraction of 3, I'm going to get 5. 5 is my input and 5 is my output. And that's because the plus 3 and the minus 3 cancel each other out. They're inverse functions. Just like addition and subtraction are inverse function, we also have multiplication and division are inverse functions. For example, I can do 25 divided by 5 equals 5 times 5 equals 25. Get my original from my input. Now the reason I just showed you this simple mathematics is that logarithms are actually the inverse function of the exponential function. For example, if I say that now 3 is my input, and I want to use that in an exponential function, I can do 2 raised to the third power, that's my input, equals 8. So now I take my 8 and I input it into a logarithm. Log base 2 of 8 equals 3. And again, my input, 3, is equal to my output. I've just undone the exponential function. So let's dissect the meaning of this a little. When we write an exponential function like 2 to the third, what we mean is multiply 2 by itself 3 times. So 2 times 2 times 2 is equal to 8. If we write a logarithm, log base 2 to the 8 equals 3, what we mean is how many of the base must we multiply to get the other number? So the base is 2. And you could think of it the same way as you do in exponential form. In exponential form, 2 to the third, 2 is the base. In logarithmic form, 2 is still the base, so the same number is the base. And the way I remember it is that if you have, say, the base of a building, it's kind of be on the lowest floor, it's going to be at the bottom. So 2 is at the bottom here, 2 is at the bottom here. The base is always written a little bit lower than the other numbers and the other letters. So how many of the base must we multiply to get the other number? And the other number is the 8. And the answer is, if you see here, we multiplied the base, which is 2, 3 times. 1, 2, 3. That gives us our answer, 3. We've multiplied 2 3 times to give us 8. So 3 is the logarithm. So what we're going to do now is go over a few examples and see if we can figure all this out and learn it a little bit better. So let's start with log base 3 of 81. What does that equal to? Well, let me start by just giving you another way to think about this. I already told you in words how many of the base must we multiply to get the other number. You could also think of this sentence mathematically, which might help some of you, is 3 raised to what power equals 81. So log base 3 of 81 is the same thing as trying to figure out what x is in this statement. So 3 raised to what power is equal to 81? Well, 3 times 3 is 9, times 3 is 27, times 3 is 81. Now there's 4 3's here. We multiplied 4 3's together to get 81. And so the answer to the log base 3 of 81 is 4. And we'll try another example. Log base 5 of 125 equals what? So how many of the base must we multiply to get the other number? The base is 5. let's just start multiplying and see if we can get close to 125. So 5 times 5 is 25, times 5 again is 125. That means I've multiplied 3 5s to get 125, so the solution is 3. Now, what if we have fractions? Everybody's afraid of fractions, so I'll throw in one of those. So we have log base, we'll use the same numbers in the previous example, but I'll just make them fractions. 1/5 of 1/125 equals what? So again, 1/5 raised to what power is 1 over 125. Let's try multiplying 1/5 out. 1/5 by 1/5 is 1/25. Times 1/5 again is 1/125. So how many 1/5ths are there? How many of the base did we multiply to get 1 over 125? 1, 2, 3. And so it's equal to 3. See, we're just multiplying the base until we get the input. Now we're going to make it a bit trickier, and instead of using two fractions or two non-fractions, I'm going to mix it up. So we'll have log base 5 of 1 over 125 equals what? Which means what we're asking again is how many times do I have to multiply 5 by itself to get 1 over 125? Well, it seems like no matter how many times we multiply 5, how are we going to get a fraction from multiplying 5? Think of it again in the other form. If I were to say 5 raised to what power equals 1 over 125? You might remember that if you raise a number by a negative power, it gives you the reciprocal. So if I had 5 to the negative 1, that's going to be equal to 1 over 5. If I had 5 to the negative 2, that's going to be equal to 1 over 25. And then 5 to the negative 3 is 1 over 125. So I have to multiply 5 by itself 3 times to get 1 over 125. But I also have to multiply, I also have to use the power negative 3. That's enough logarithms for now. I think you've got the basic idea. But I just want to go over one more thing before we go, and that is the syntax. We've been writing logarithms as log base a of x is equal to some value y, where a is the base and x is your input. There's a few logarithms, there's a few bases that are used so frequently that they have their own syntax. The first one is base 10. You would simply write, to write the above, you would simply write log of x equals y. So to be specific here, if you were to see log 100, that would be equal to 2. And the reason is, what this actually means is log base 10 of 100. So how many times do you multiply 10 together to get 100? 2 times. 10 times 10 equals 100. And then the shorthand way to do this is that you just count the number of zeros. The number of zeros is going to be the number of times that you have to multiply 10 together to get 2. For example, log base 10 of 100,000 is going to be equal to 1, 2, 3, 4, 5 is going to be equal to 5. 10 times 10 times 10 times 10 times 10. Counting the zeros is just the quick way to do that. But you wouldn't see these written log sub 10 of 100,000. Most likely you would see log of 100 equals 2. And just leave out the 10. And that's the most common form in engineering disciplines. Now in mathematics, in the field of mathematics, there's another base that's used very frequently, and that's the natural log. So using our original notation, I would write log base e of x equals y. E is Euler's number, and it's a very special number in mathematics, similar to pi. We're not going to go over that in this tutorial, but maybe in future tutorials I'll explain that. And instead of writing it out like this, there's a shorthand way, and it's simply ln of x equals y, where ln stands for the natural log. So that's really all there is to the fundamentals of logarithms. If I've saved at least one of you from indentured servitude, then I've done my job. As always, if there's any questions or comments or confusion, go ahead and leave comments below. That's it. Bye.